Hello there, welcome back to the new video. So this video is part of the series where I talk about methods or techniques for learning sentence embeddings in an unsupervised fashion. And for that we are following Sentence Transformers GitHub repo where they have listed a bunch of methods that they have implemented. In the previous videos in the series we have gone through TSDAE, SimCSE, CT, CT in bash negative sampling, and masked language modeling. In today's video, we'll be touching on GenQ, which is from the paper Beer, a heterogeneous benchmark for zero-shot evaluation of information retrieval models. But before we move forward, in case you're interested in seeing the remaining paper summaries, do check the comments of this video. I've pinned all the videos in this series, so feel free to check them out. Cool, so let's start off with GenQ. So this paper essentially proposes a pretty interesting way of training these models. So as we all know, right, biencoders are pretty much the current best way of training these kind of tasks. But again, the drawback is like they require supervised data. You'll need to have anchor positive pairs or anchor positive or negative pairs. And creating all of this for your domain is always not possible. So what GenQ does is that it trains a biencoder, but the data creation process is synthetically done. Okay, so let's break it down to what it means. So let's say you're talking about any domain D of which you have a lot of unlabeled data that they with you. And let's consider these are the passages 1, 2, 3, 4, and 5. So think of this as the documents that are to be retrieved for a certain query that the user will eventually fire. So the next step for this is to generate questions or queries that user might possibly ask for which the answer lies in their respective passages. So they essentially train a T5 model that takes in a passage and generates a query out of it. And I think they do it for MS Marco dataset, and which is what they use for further experiments. So for every passage, they would go ahead and generate 3 questions or queries. So think of a scenario where, let's say, you're talking about LLMs. So this paragraph generally described what LLM is. This described the pros of using LLMs, this described the limitations of LLMs, this described the risk and safety associated with LLMs, and so on and so forth. So with every passage or every document, you will have unique kind of questions that you would be essentially asking. So here you might ask, let's say, what is an LLM? What is LLM used for, and so on and so forth. So these could be, let's say, 2 questions that you generate, and possibly the answer of that would lie in this. So you'll have 2 pairs already generated. One is Q1, one is Q2 with passage number 1, passage number 2, and this is your positive and anchor pair that you use for the first passage. And similarly, you keep on generating from every other passage. And once this is done, you will have pretty decent sized pair dataset with queries what your T5 model generated and the relevant passages from which it was generated. So we can suffix it by ith passage. You will have ij questions where for every I, j goes from, let's say, 1 to 3 or 5 or whatever number you choose. And I hope now it's clear from here, right? I mean, you already have a pair dataset that you have created about training a biencoder model on one of the relevant losses. The paper uses MNRL, which is multiple negatives ranking loss, which is mathematically defined as -1 by m, where m is nothing but the number of batches. You go from 0 to all the m-1, then log of e to the power sigmoid, then similarity between the embedding of qij and pi. And you can also have a normalization for softmax with the tau or temperature. You divide by, for all the elements that are there in that batch, from 0 to n-1, e of sigma qij comma pi. Okay, so this will be just qi because in numerator you need to calculate the closeness between the positive pair, and the denominator accounts for all the negative pair that you create from that batch. So now if you see, if the training happens properly and your embeddings are pushed closer for the positive set, the sigmoid of that will tend to 1. And for the cases where the dot product is really low, and this would be for the cases where the question is not derived from that passage but you're still putting that in a pair, so that model also learns the notion of what it should pull apart. So this value is less, so sigmoid goes to 0, this entire value is low, overall this becomes really high, which makes the entire term tend towards 0. So that's how the multiple negative ranking loss is defined, and this is exactly that the paper uses for training this model. So yeah, that's it for this paper. Now if you think pretty closely, it's not something really out of the box that they've done, but again, the novelty is all in the simple things. It's just about you thinking through and clicking on that idea. Okay, so that is for this video. In the next one, I'll touch upon GPL, which is generative pseudo labeling for unsupervised domain adaptation of dense retrieval. So this is again in the similar lines as they have written CGPL for the improved version that uses multi-step training process. So this paper also touches upon in the similar lines but has some nuances that we'll see when we meet next time. Until then, make sure to hit the like and subscribe button. I'll meet you in the next one. Bye bye and take care.